All right. Hello, everybody. This will be our second mini presentation. And the group who's doing this is Chris Park, Chris Bedios, Nicholas Frizzell, and Alex Prinzeski. And our team name is Team Drone. So a little bit about some background information. So Eric Legrand suffered a severe spinal cord injury, and this caused him to be paralyzed from the neck down. And this means he can't use his arms and legs. So if he can't use his arms or legs, it seems that you can't really perform in any other sport. But for this game of cornhole, we'll have a drone carry from one beanbag from one point to another.
The first piece of data we collected in this project was the weight limit of the drone harness without compromising the flight integrity of the drone. We found out that the optimal weight capacity for a drone was to fly 450 grams of attached weight, and this would provide no issues with the flight pattern. This value was an ultimate necessity and deliverable of ours because we must ensure that the drone does not attempt to fly a weight outside of its capabilities. This value was achieved by conducting a simple test flight and then increasing the weight in increments until we achieved the weight of 450 grams, whereas any additional weight would compromise the drone's flight. And here's a demonstration video of a weight simulation test that we performed. Here, the shoe was filled with weight to replicate the weight of the beanbag and demonstrate the undisrupted flight of the drone.
The second measurement that we will be taking is the drone battery life. This important data sample was easily gathered by conducting live experiments as well as online research. We essentially needed to find the battery life in terms of time duration of the DJI Mavic Pro drone. This was found to ensure that our target population would have enough time to complete a game of cornhole without the drone losing its battery charge. That value was determined to be a reasonable set of values, assuming different conditions. First, we had 27 minutes, assuming no wind at a consistent 25 kilometers per hour, 24 minutes with no wind, and 21 minutes in normal flight with 15% remaining battery. To ensure a proper game of cornhole can be played, we needed to find out the distance the user can be from the drone whilst maintaining operation and command of the drone through the remote. This was necessary since cornhole is an outdoor game primarily and can be subjected to factors from the environment such as severe winds or tall trees that can disrupt the flight path and potentially create an obstacle for the drone. After research and testing, that value was determined to be 8 miles.
For this set of data collection, we needed to determine the Gauss strength of the electromagnet. This set of data is necessary since we need to ensure that our magnet can carry a minimal weight of 450 grams, which is the weight of the beanbag. We also need to make sure that the attraction between the magnet and the electromagnet can overcome the beanbag's fabric, separating the two. Nonetheless, these data values are still under investigation, whereas the electromagnet circuit is still under development. And for our technical questions, we have what data collection hasn't occurred yet? And the answers are the signal strength of the drone as a function of distance, the battery life of the drone as a function of time, the Gauss strength of the electromagnet, or none of the above. And for number 2, what is the optimal weight limit of the DJI Mavic Pro drone? A, 4,000 grams, B, 1,000 grams, C, 150 grams, D, 450 grams. Thank you.